Alright, so yesterday we tried sketching quadratic functions in vertex form by using a step pattern. Today we're going to do something a little bit different. So what we're going to do today is, for example, you can take a look at this. So this red graph here is the equation y equals x squared. And I've labeled 3 points on that equation. You have 0, 0. And you have the point 1, 1, and you have the point minus 1 and 1. This graph over here is another equation. I wrote it as 2 times x minus 3 squared plus 1, for example. And what we're going to do to be able to graph this one today is we're going to take each of these 3 points and find out where they moved to on this graph. So it's called point-to-point transformation. So this 0, 0, it moved to here. So what is that point? This 1, 1, where did it move to and what is it point? And this minus 1, 1, where did it move to and what is its coordinate? Once we know those 3 points, we can sort of do a sketch of what that quadratic would look like. So let's look at those values of A, H, and K again. Well, we know what the vertex is. That's H and K. Okay? And whether or not A is positive or negative will tell us whether or not it opens up or opens down. But the value of A will affect the y-coordinate. Okay, so you have an ordered pair, like your x-y coordinates. A will affect the y-coordinate. How will it affect the y-coordinate? Well, what we're going to do is to determine our new transferred point, we're going to multiply, since A is multiplying, the value of A by that y-coordinate. So what exactly do I mean by that? Let's go down to this example. So we have our 3 points that I showed you for y equals x squared. Now in this example, our value of A is 2. So that's a stretch, it's not a compression. And it's opening up. So we're not going to get a reflection there. So what we do first is we multiply A by the y-coordinate. Now in this case you have a y-coordinate of 0. And 2 times 0 is still 0. But you would do, there's your x-coordinate. And then we're going to multiply our y-coordinate by 2. Now in this case it doesn't change anything because, like I said, 2 times 0 is still 0. But in another case, in this one, we're going to multiply our y-coordinate by 2, and it's 1. So we get a new coordinate of 1 and 2. And for our last one, again, it's 1 as well. So we have minus 1 and 1. We're going to multiply. Forgot to write the multiply in there. Okay, and we're going to get minus 1 and 2. So that's our first transformation there. Next, what does H do? Now H, if you remember, gives us a horizontal shift back and forth. So that's going to affect our x-coordinate. And what we're going to do, since H, we either add units to the right or add units to the left, we're going to add or subtract the value of H to our x-coordinate. So let's do that with the example below. So in this example, our value of H is 3. Remember, it's in the bracket, so take the opposite sign. So that's a phase shift to the right. Since it's to the right, we're going to add that value. If it was to the left, we would subtract it. So here's our point 0, 0 after that first transformation. But we're going to add 3 to the x-coordinate. and the y-coordinate will stay the same. So that is our second transformation. We get 3 and 0. Over here we have 1, 2, but again, we're going to add 3 to that 1 there. So we'll have 1 plus 3 and 2. So now our new coordinate is 1 plus 3 is 4, and we're left with 2. And the same thing for the last one. We have negative 1 plus 3, and our y-coordinate stays as 2, which gives us the coordinate 2 and 2. So those are our three coordinates after our second transformation. But we still need to do a transformation for k. So what does k do? Well, again, if you remember, k is our vertical transformation. It changes our graph up and down. So k is going to affect the y coordinate. And since we move it either up a certain number of units or down a certain number of units, we're going to add or subtract that value of, I should say, k, that value of k to the y coordinate. So when we do that, in this case, you can see our value of k is just 1. Since it's positive, that's a shift up. And so we're going to add, not subtract. If it was down, we would subtract. So here's our coordinate after our second transformation. So we're going to apply the last transformation and add 1 to our y coordinate. X will stay the same. So we have 0 plus 1. So that gives us our final transformation point as 3 and 1. We can do the same thing here. So here we have 4 and 2. And we're going to add 1 to our y. And that gives us our final point of 4 and 3. Similarly for the last one, we have 2 and 2, but we're going to add 1 to the y. So 2 plus 1 is going to give us our final point, 2 and 3. So what does this actually look like? So here's our graph. Right there of y equals x squared. And you have our 3 points. There's 0, 0. There's 1, 0. 1, 1. And there's minus 1 and 1. Okay. So our first point, our 0, 0 point, that moves to 3 and 1. So we're going to plot 3 and 1. So there's 1, 2, 3, and 1 right there. It moved from here to there. Our next point right here, which was 1 and 1, is now going to be 4 and 3. So there's 4 and 3. So this point has moved right there. And our last point, which was minus 1 and 1, is now 2 and 3. So it moved to 1, 2, and 1, 2, 3, right here. Okay, so now that you have your new 3 points, sort of sketch a rough look of what our new quadratic would look like. Okay, let me pause there. I know that was a lot. All right, so filling out that chart may take a while, but an easy way to summarize what we did, which we call mapping notation, is to take your original coordinates, and what you're going to do is your x coordinate, you're going to add the value of h, right? And if h is negative, then obviously you're subtracting h. And then your y coordinate, you're first going to multiply it by a, and then you're going to add k. So let's try another example. Let's see if we can do this a little bit more quickly as opposed to drawing a whole table and filling it out. So I'm just going to make this out. Let's look at y equals 3 times x minus 1 squared plus 4. Okay, so originally your 3 points are for your y equals x squared 0, 0, 1, 1, and minus 1 and 1. Right? That's these 3 points here. And we're going to translate each one, or transform each one. So our first one, 0, 0. Well, let's look at what A, H, and K are. It's important to identify those. So here's A. So A is 3. H is positive 1. Remember, you take the opposite sign. And K is 4. Okay, so the point 0, 0, we're going to transform it. So 0 plus H, where H is 1. So 0 plus 1 is 1. Okay. Next, we're going to take our y coordinate, which is 0, multiply it by A, which is 3. So 0 times 3 is 0. And then we're going to add K, which is 4. So 0 plus 4 is 4. Okay, let's do it again for the next point. So x is 1, and we're going to add h, which is 1. 1 plus 1 is 2. Take our y coordinate, which is 1, multiply by a, which is 3. So 1 times 3 is 3. And then add k, which is 4. So 3 plus 4 is 7. There's our next point. And our last point, notice that the last point starts with the exact same y coordinate. So you're going to end up with the exact same transformation. You'll get 7. X will be different though. X is minus 1 plus h. So minus 1 plus 1 is actually 0. And you should notice a pattern there because there is symmetry. If we look up at a quadratic and you split it in half, what you see on one side will be the same with what you see on the other side. So notice these 2 points are still on the exact same level. It's just one's to the right of our vertex and one's to the left of the vertex. And they're to the right and to the left the exact same amount. So here, you have them at the same level. Here's your vertex. And one's one higher than that, and the other's one lower than that. So if we were to graph this example on the one above, here you have the point 1 and 4, which would be 1, and 1, 2, 3, 4. There's your vertex. And then 2 and 7, so 1, 2, 1, 2, 3, 4, 5, 6, 7. And then even without looking at the third point, I know it's going to be on the same level at the other side, which works, right? 0 and 7. And then you can graph that one, like so. Okay. Pause there.